Hi everyone, welcome to Mathworld. This is Cambridge International AS and N-Level Further Mathematics, Paper 1. The code is 9231/12 for October-November 2022. Okay, so let's move on to question 1. Now A, use the list of formula to find summation R times R plus 2, the R from 1 until n in terms of n, simplifying your answer. Alright, so now we will start with summation R, bracket R plus 2, the R from 1 until n. Firstly, we will do the expansion. So here will be summation R squared plus 2R. Okay, so R from 1 until n. So from here, we can split it into two summations. So summation R squared, the R from 1 until n, and the other one is 2 summation R from 1 until n. Okay, so according to the formula, the list of formula, the first summation formula is 1 over 6n bracket n plus 1 times 2n plus 1, and for the second formula, summation R will be half times n bracket n plus 1. Okay, so from here, we may simplify 2 and half. Okay, and since there is one fraction here, fraction from the same first expression, which is 1 over 6, we may factorize 1 over 6, and then the n is in common as well as the n plus 1. So we will factorizing n and n plus 1, and then the remaining term will be 2n plus 1 for the first expression. And the second term, once we have factorized 1 over 6 from the second term, here we'll have 6. Therefore, from here, we will get the answer 1 over 6 and n plus 1 together with 2n plus 7. That is our summation. Okay, so now let's move on to B. Now express 1 over R times R plus 2 in partial fractions and hence find the summation from R from 1 until n in terms of n. So first of all, we have to find the partial fractions. So since this is proper rational function, right, and the denominator has 2 linear factors, therefore our partial fractions will be A over R plus B over R plus 2. Now by getting the same denominator as in the left and right hand side, the second term we need to multiply by R plus 2. Okay, the first term on the right side, which is the A over R, we have to multiply by R plus 2. And then for the B, we need to multiply by R. Now, since both denominators are the same, therefore we are going to just write down the numerators. So now to find the A and B, let the factor be 0. So when I let R plus 2 be 0, my R will be minus 2. So 1 equals to, since the R plus 2 equals to 0, so R plus 2, 0 times A, it will be 0. Therefore, we can find the B. So B times minus 2. Therefore, my B is basically negative half. Now, next, we will let the next factor be 0, which is the R, which means now my R equals to 0. So 1 equals to 0 plus 2 is 2A. Therefore, I'm getting 1 equals to 2A. Hence, my A will be positive half. Okay, so now just need to rewrite to get the partial fractions. So my partial fractions will be half over R. So normally we do not write half over R. What you need to do here is we will write half bracket 1 over R. Okay, that is our A over R plus B over R plus 2. So since the B is negative half, so the plus and minus becomes minus. Therefore, we have to factorize the negative half and write 1 over R plus 2. So that is our partial fraction. Okay, so because of this word hence means use the previous partial fraction to solve the next part. Now, we need to solve summation 1 over R plus 2, the R from 1 until n. It is the same as summation of the right side. So now, since both terms with half, I may factorize the half and then consider summation. 1 over R minus 1 over r plus 2. Okay, so to solve this summation, right, you can just replace the r values. So when I replace, I will start with the r equals to 1. So 1 over 1 will be 1, then minus 1 over 1 plus 2, which is 1 over 3. Okay, then now here, you must simplify. So the next r will be 2. 1 over 2 minus 1 over 2 plus 2 becomes 4, plus 1 over 3 minus 1 over 5. Okay, to get more terms, right, so that we can see the pattern of the cancellation. So I will find next term, 1 over 4 minus 1 over 6, because the r is 4. Then 1 over 5 minus 1 over 7. Okay, so from here we notice that, right, the 1 over 3 will be cancelled off, 1 over 4 will be cancelled off, but the first two terms, I mean the 1 and the half, will not be cancelled off. Means that we need to remain the last two terms, okay, in our next working. So negative 1 5 and 1 5. So all this will be cancelled off, right? All this will be cancelled off. So what we do here is we just write plus dot dot dot. Okay, I need last two terms. So my last term is when the r equals to n. So I will get 1 over n minus 1 over n plus 2. Then my term before the last term, the second last term happens when the r equals to n minus 1. So I will get 1 over n minus 1. So I replace it here. Then when my r equals to n minus 1 plus 2, it will be n plus 1. Okay, so after you get this, just now we notice that first and third term cannot be cancelled off, which means the first and third from the back also cannot be cancelled off. In other words, this 1 over n and 1 over n minus 1 will be cancelled off. Right? So this is how you cancel the terms. Now, here we will be getting 1 over 2. Write down the remaining terms, 1 plus half, and then minus 1 over n plus 1, and minus 1 over n plus 2. Okay, so you can leave your answer in terms of n. Probably you can just simplify the first two terms, which is 3 over 2 minus 1 over n plus 1 minus 1 over n plus 2. So that is our summation. Okay. Now, deduce the value. So this value, this sum, is similar to the previous sum. Okay. The sum from 1 until n. It's just that now we have to change to r from 1 until infinity. So I may write summation r from 1 to infinity, 1 over r plus 2 is basically the limit when the n tends to infinity for the summation 1 over r plus 2, whereby the r starts from 1 until n. Okay, since we have found the summation just now, so I will just write it down, which is half of this whole bracket. So I will write half of 3 over 2 minus 1 over n plus 1 minus 1 over n plus 2. Okay, so we know that when you consider n tends to infinity, this whole value will tend to 0, because 1 over infinity here will tend to 0. Therefore, our final answer will be just 3 over 4. Okay, that is the solution for this question. Right? So, with this, we have completed question 1. Okay, so let's move on to question 2. Now, the equation x degree 4 plus 3x squared plus 2x plus 6 equals to 0 has roots alpha, beta, gamma, delta. So find a quartic equation whose roots are 1 over alpha squared, 1 over beta squared, 1 over gamma squared, and 1 over delta squared, and state the value of the sum. Right, so here we have to solve two parts. The first is equation. The second is state the value, the sum of the values. So now, what we do here is, okay, since your equation here in terms of x has these four roots, alpha, beta, gamma, delta, so now I will let my y be 1 over alpha squared, 1 over beta squared, 1 over gamma squared, and 1 over delta squared. So now from here, I will say that my y is basically 1 over x squared, because when your equation in terms of x, it has roots alpha, beta, gamma, delta, means all these are basically the x. Alright, so now here I get the relationship between x and y. So now my x will be 1 over y squared. Therefore, my x will be 1 over square root y. Now, substitute this x into the given quartic equation. So, x degree 4, right, I will rewrite x degree 4 plus 3x squared plus 2x plus 6 equals to 0. Now, my x is 1 over square root y. So, I will replace my x by 1 over square root y. Okay, and then now here we need to simplify. So, degree 4 of 1 over square root y is basically 1 over y squared. Square of 1 over square root y is basically 3y. So 1 over y. So 3 times 1 over y, I'm getting 3 over y. Then plus 2 over square root y plus 6 equals to 0. Now, when we need to form the quartic equation, right, make sure there's no square root y. It should be degree 1, degree 2, up to degree 4 for the y, together with a constant. So, now what we need to do here is, we times y squared first, right? We times y squared. So, first term becomes 1. Second term is 3y. Third term will be 2y degree 3 over 2, because the square root y is basically y degree half. Right, plus 6y squared equals to 0. And now we need to eliminate the y with degree 3 over 2. So we will keep this, the term, 2y to the power of 3 over 2 on the left side, and the rest of them move to the right side. Okay, so 2y to the power of 3 over 2 equals to minus 6y squared minus 3y minus 1. Now to eliminate the square, right, the square root, here 3 over 2, the square root, the over 2 here. So we need to square both sides. So when square both sides, 2 squared will be 4. Y to the power of 3 over 2 and then square. The square and half will be cancelled off, becomes y degree 3. Okay, so for the right side, since you need to square 3 terms, therefore you can expand one by one. Now, for your information, before you multiply, right, you may factorize the minus. Okay, so that will be easier. So I may factorize the minus. All right, so when you square the minus, it will be positive. So I will just do the extension. So when you expand one by one, 6y squared times 6y squared, 36 y degree 4. 6y squared times 8 times 3y, 18 y degree 3. 6y squared times 1 plus 6y squared. And then here you do multiplication or expansion, 18y cubed plus 9y squared plus 3y, and then followed by plus 1. Okay, 1 times all these brackets, all these terms. So I will get plus 6y squared plus 3y plus 1. Okay, so now try to simplify it. I need cube, quartic. So 36y degree 4. Okay, so here is my 4y cubed. So now you can just simplify. 4y cubed when you move to the other side, becomes minus, together with this 18y cubed, and here 18y cubed. So at last, we will be getting plus 32y cubed. Okay, so for the y squared, here's 6y squared, 9y squared, 6y squared. Total will be 21y squared. And then for the y, we have 3y and 3y, therefore 6y. That equals plus 1 equals to 0. So this is how we solve the quartic equation. Okay. So once you have found the quartic equation, right, don't forget to state the value of the summation. Now, this value of the summation, 1 over alpha squared plus 1 over beta squared plus 1 over gamma squared plus 1 over delta squared is basically summation of the root. Okay, because now your root becomes 1 over alpha squared and so on. So if you still remember, summation of the roots is basically equal to minus b over a, right? Whereby your b is 32. So from here, your a is 36, your b is 32, c is 21, d is 6, e is 1, right? So summation of the roots equals to minus b over a. Therefore, minus 32 over 36, and you can simplify it to minus 8 over 9. That is how we solve the summation of the roots. Okay, so let's move on to B. Now, to get the summation of the squares of any three roots or any three parameters, right? So now here, 1 over we notice that this is basically 1 over alpha squared plus 1 over beta squared. You can get it from this sum. Okay, that's right. You have found the sum just now. So when we do the expansion for this, it will be alpha squared, beta squared, gamma squared, delta squared. So make all this to same denominators. So it will be beta squared, gamma squared, delta squared, plus alpha squared, gamma squared, delta squared, plus alpha squared, beta squared, delta squared, plus alpha squared, beta squared, gamma squared. Okay, so now the numerator is the expression that you need to find. Okay, the value that you need to find. Now we will start with from 36y degree 4 plus 32y cubed, the quartic equation that we have just formed. All right. So from here, we know that A is 36, B is 32, C is 21, D is 6, and E equals to 1. So we know that summation 1 over alpha squared, this is same as summation alpha prime. I let my alpha prime be the 1 over alpha squared, 1 over beta squared, 1 over gamma squared, and 1 over delta squared. So here will be minus b over a, which is negative 32 over 36. Okay, or you can say that it is same as negative 8 over 9. So here is 8 over 9. So we found just now. Okay, and then so this value found. Now to get this numerator, we need to know what is the denominator. So denominator is basically alpha, beta, gamma, delta prime. Okay, so from here, right now from here, basically we know that one more value, summation 1 over alpha. Oh, I would say, okay, 1 over alpha prime, beta prime. Okay, summation alpha prime, beta prime is C over A. So C over A is 21 over 36. Right? So this is 7 over 12. Now I need to find this value, the denominator. So I need to refer to the original Quartic equation, which is in terms of the x. Alright? So when I times all this together, that will be the alpha, beta, gamma, delta. So now from x degree 4 plus 3x squared plus 2x plus 6 equals to 0. So from here, the A equals to 1 because 1x degree 4, B is 3, B is 0 because there's no cube, C is 3, D is 2, E is 6. We know that alpha, beta, gamma, delta is going to be E over A, which is 6 over 1. Okay? Now, from here, I will be writing my equation. So, I let this be first equation. I rewrite so that my numerator is the subject. So, from first of beta squared, gamma squared, delta squared, plus alpha squared, gamma squared, delta squared, plus alpha squared, beta squared, delta squared, plus alpha squared, beta squared, delta, gamma squared. Okay, so these four numerators will be this summation times the square of the product. So I will write this is basically the summation squared which is this summation squared, right? So sigma 1 over alpha squared multiplied by alpha, beta, gamma, delta squared. So we have found this value just now, negative 8 over 9. And alpha, beta, gamma delta is 6. So 6 squared. So at last we'll be getting negative 32. Okay, so this is how we solve this question. Right? So now, lastly, find the value of summation for cube. Right? 1 over alpha cube. No, power 4. Right? Summation of 1 over power 4 of the original root. So here, 1 over alpha 4 plus 1 over beta 4 plus 1 over gamma degree 4 plus 1 over delta degree 4. So from here, I would say that this is same as 1 over alpha squared and squared, right? So 1 over beta squared and then another squared plus 1 over gamma squared and square of 1 over delta squared, which is summation alpha prime squared. Because my alpha prime is 1 over alpha squared, beta squared, gamma squared, and delta squared. So here, according to the formula, this is summation alpha prime squared, square of whole summation, minus 2 summation alpha prime, beta prime. So we have found just now, summation alpha prime is basically minus 8 over 9. Square this, minus 2. Summation alpha prime, beta prime, I have solved just now, which is 7 over 12. Okay, so here, 7 over 12. So at last, you'll be getting minus 61 over 162. So that is how we solve part C. Okay, so now let's move on to question 3. It is matrix question. Now the matrix M is given by 1, 0, 0, k times 1, 0, k, 1, where k is a constant and k cannot be 0 or 1. Right now, the matrix M represents a sequence of two geometrical transformations. State the type of each transformation and make clear the order in which they are applied. So, for your information, if it is two geometrical transformations, the first one is the matrix at the back, right? So 1, 0, k, 1 is the shear in y direction, okay, in the y direction, right? Then followed by a stretch parallel to the y-axis with scale factor k. Okay, so this is the transformation, the combined transformation. Now B, write M inverse as the product of two matrices, neither of which is I. I means identity. So what we do here is just do expansion for the M, right? So your M equals to 1, 0, 0, k multiplied with 1, 0, k, 1. So to perform the multiplication of matrices, right? So it is the same as inverse for both sides, right? So when you take the inverse of this, all right, this is M, you can either do expansion first and then followed by getting the inverse. Otherwise, you can just take inverse both sides. But when you take inverse both sides, that will be, right, that will be 1, 0, k1 inverse. So you need to inverse it because we know that AB inverse is same as B inverse times A inverse. So here will be 1, 0, 0, k inverse. So to get the inverse matrix, all right, the determinant 1 times 1 minus 0 times k, that is the determinant. Then now you need to swap, all right? So swap the diagonal 1, 1 and 0 to, and for the 0 and k, you multiply by negative. So that is our first matrix, multiply by 1 over determinant of the second matrix, 1, 0, 0, k is basically 1 times k minus 0 times 0. Then multiply with, you swap the 1 and k, okay, swap the 1 and k, becomes k1. Then the two zeros, you multiply by negative. So it doesn't change it. So now, the first denominator or the first determinant, I would say this is determinant. So 1 times 1 is 1. 1 minus 0 is still 1. Therefore, the first determinant, it will not be affected. 1 over determinant will not be affecting the answer. So I will just write 1, 0 minus k1. So here is 1 over k. Okay, for the second one, it's 1 over k. So 1 over k, you can multiply, right? So here, when you multiply 1 over k by k, it will be 1. Then 0, 0, 1 over k. Okay, so this is how we write M inverse as the product of two matrices. Okay. So now, see, show that the invariant points of the transformation represented by M, invariant points, lie on the line. Okay, so for invariant points, mxy equals to xy. All right, so now we need to get the M first. So the M from previous question, 100k. Here, 100k. Then 10k1. Okay, so when we do multiplication, right, 1 times 1 is 1, plus, okay, the operation is here. 1 times 1 is 1, plus 0 times k is 0. Okay, then 1 times 0, 1 times 0 is 0. 0 plus 1 is still 0. Okay, then here, 0 times 1 is 0, but k times k squared. Okay, lastly, second row times second column. So 0 times 0 plus k times 1. So it's 0 plus k. Therefore, we are getting 1, 0, k squared and k. That is our m. Right? And now we need to show that the invariant point lies on this line. So once you have found the m, substitute into this equation. So now, mxy, so 1, 0, k squared k xy equals to xy. Okay, so again another multiplication. So row times column. 1 times x plus 0 times y, 0. Okay, then k squared times k times x, it will be k squared x plus k times y. Ky equals to xy. Okay. Now, from here, we just compare. So, now, I will compare the y coordinate, okay, the y position. So, my y equals to k squared x plus ky, because the first row is the same, x left side and x on the right side. So now, we need to show y as a subject. Okay, so move the ky to the left side, and then factorize the y. Therefore, your y will be k squared over 1 minus k times x. Right? So we have proven that. Okay? Now D. The triangle ABC in the xy plane is transformed by by m onto triangle DEF. Okay, find the value of k for which the area of the triangle DEF is equal to the area of the triangle ABC. Alright, now area of triangle DEF will be determinant of m times area of triangle ABC. Alright, so since they are the same, now you see here, area of triangle DEF is equal to area of triangle BCD, which means this area can be cancelled off. Both area can be cancelled off. Now, once you cancel off left side is 1. So the determinant of m, alright? So determinant of m refer to the matrix m, 1, 0, k squared k. So here 1, 0, k squared k, right? So 1 equals to determinant is 1 times k plus 0 times k squared. So obviously k equals to 1. Okay, so done question 3. Now let's move on to question 4. The function f is such that f double prime, the second derivative, is equal to fx. Proof by induction. For every positive integer n, you differentiate 2n minus 1 times of x fx, it will be x f prime x plus 2n minus 1 multiplied by fx. So now let Pn be d 2n minus 1 over dx 2n minus 1 x fx equals to x f prime x plus 2n minus 1 times fx. You let whatever you need to prove be the Pn. Okay, so now we need to prove when n equals to 1. So when n equals to 1 means that left-hand side, you need to get b 2 degree 1 minus 1 over b x 2 degree 1 minus 1 x fx. Okay, which means 2 times 1 is 2, 2 minus 1 is 1. So you need to differentiate 1 time of x fx. So to differentiate this, we need to apply the product rule. So keep the x, differentiate fx, is f prime x, plus keep the fx. Differentiate x is 1. Okay, this is what we get. Now, for the right-hand side, when the n is 1, so I will replace x f prime x plus 2 bracket n is 1, minus 1, times fx. So which means I will be getting x f prime x plus 2 times 1 is 2. 2 minus 1 is 1. So 1 times fx is fx. So obviously, these two are the same. Alright? So left-hand side equals to right-hand side. Therefore, P1 is true. Okay? So now, assume n equals to k is true. Okay, therefore, we will be getting P bracket k, which is referring to d 2k minus 1 over dx 2k minus 1 x fx. So you just need to change the n to k. I will get x f prime x plus 2k minus 1 fx. Okay, so now when n equals to k plus 1, so I will get pk plus 1. It will be d 2 bracket, the k will be changed to k plus 1, then minus 1 over dx 2 bracket k plus 1 minus 1 of fx, x fx. Alright, so now let's simplify first. This is d 2k plus 2 minus 1 plus 2 minus 1 is plus 1. Okay, so now we have d 2k minus 1. This is 2k minus 1, but right now we have 2k plus 1. So to use this result, we need to get 2k minus 1 from 2k plus 1, which means now, okay, basically I need to change d 2k plus 1 to be 2 bracket 2k minus 1. Okay, so I need to get 2k minus 1. So now I will write 2k minus 1 so that I can refer to this form. Then to get plus 1, I plus 2 outside. Okay, over d 2k minus 1 plus 2 outside. this means, okay, d squared over dx squared, right, because of the plus 2. So, of d2k minus 1 over dx 2k minus 1 for x fx. Right? So now I already found this or already obtained this expression. Therefore, I'm going to replace by these two terms. So d squared over dx squared x f prime x plus 2k minus 1 times fx. So now I need to differentiate 2 times. Firstly, okay, when you differentiate x f prime x, again, this is product rule. Keep the x and differentiate f prime x. So it will be f double prime plus keep the f prime x, differentiate x is basically 1. Okay, then plus, don't forget that this 2k is, the k is a constant. So when I differentiate constant fx, it will be constant f prime x. Okay, and now don't forget that you were given f double prime x is fx. Okay, so I will rewrite. This is basically d over dx x f double prime. This double prime x will be changed to fx plus f prime x plus 2k minus 1 f prime x. Okay, so or probably you can simplify these two terms. It will be 2k fx f prime x. So now differentiate one more time to get the answer. So again, keep the x, differentiate fx to get f prime x, plus keep the fx, differentiate x is 1, plus 2k f prime x becomes f double prime x. So again, f double prime x is fx just now, okay? Is given in the question. So from here, I will get x f prime x plus 2k plus 1 fx. Because the fx is in common now. Now, this form, okay, is exactly, not exactly, it will be similar form if you change the k to k plus 1. Because if I'm changing to k plus 1, I'm getting 2k plus 2 minus 1, which is plus 1. This is what I have obtained, right? So, which means the p of k plus 1 is true. So, by mathematical induction, Pn is true for all positive integers of n. Okay, so this is the solution. Now, question 5. The curve C has polar equation I equals to a secant squared theta, where a is a positive constant and theta between 0 and pi over 4. Sketch C, starting the polar coordinates of the point of intersection of C with the initial line and also the half line theta equals to pi over 4. Okay, so before we solve, we need to calculate the values. So your theta from 0 to pi, we may count 0, pi over 12, pi over 6. Okay, we get more points. And then pi over 4. Right? So now when you calculate, all will be in terms of A. So here, A, 1.07A, and then 4 over 3A, 1.59A, and 2A. Now, we need to draw the lines. Okay, say here is 90. So you need to use the ruler, okay, and protector. So let's say pi over 4 is here. Right, you need to state the polar coordinate of the points of intersection C with the initial line and also the half line. So this is pi over 4. And then pi, this is pi equals to 0. Okay, so now I will get pi over 6. Let's say pi over 6. Okay, then I found pi over 12, which is half of pi over 6. And followed by 5 over 24 pi. So you just measure the values. Here, when theta equals to 0, let's say here is A. Okay, then slowly increase, it will be, let's say here is 2A. Now you have to measure. You can let the A be 2 units. Okay, so maybe the shape will be like this. Right, this is your curve C. Okay, so now B, find the maximum distance of C from the initial line. So, okay, wait. We have sketched a C. Now you need to state the points of intersection of C with the initial line. So for initial line, it will be 0, right? So the coordinates, here you should write coordinates equals to 0, A. And then the half line, pi over 4. So when pi over 4, it is 2A. So here, pi over 4 and 2A. These are the coordinates for the two intersection points. Okay, now B, find the maximum distance of the point from the initial line. Initial line is theta equals to 0. Now, in order to get maximum distance, we know that from the polar coordinates, r equals to r sine theta. All right. So the maximum distance obviously is at when theta equals to pi over 4. So you just write when theta equals to pi over 4, your y will be r sine theta. Okay, your r is basically 2a. This is your 2a. Right? So replace the r by 2a. So I get 2a sine pi over 4. So you'll be getting 2a 1 over square root 2. Hence, the distance is square root 2a. So this is the maximum distance from the point C, from the initial line. Now C, find the area of the region enclosed by C, the initial line and the half line, theta equals pi over 4, means you need to find what is the region for this. So area of the region is basically half integrate r squared d theta. The theta from 0 until pi over 4. This is the formula. So half integrate 0 to pi over 4. Now, your r squared, okay, your r is a second square theta. So when you square both sides, it will be a squared second degree 4. So a squared second degree 4 theta d theta. Now to integrate second degree 4, okay, or first of all, factorize a squared because this is a constant. So to integrate second degree 4, you may change to second squared times second squared. Okay, and then we know that 1 plus tangent square theta is second square theta. So change the second term to 1 plus tangent squared theta. And then here we are going to do the expansion. So second squared theta times 1, you'll be getting second squared theta. Then the next one is second squared theta times tangent squared theta. Okay, so for the second integration, we are going to use substitution. Let u equals to tangent theta du equals to second squared theta d theta. Right? So for this integration, we are going to use substitution. And now, when you use substitution, you need to get the new u values, the new limits. So when theta equals to 0, your u is 0. Theta equals to pi over 4, your u will be 1. So from here, I will split it into two integrations. So for the second integration, which is this, u equals to tangent theta. So which means this is my u squared. Okay, second squared d theta is basically here, second squared d theta. Therefore, I will have d theta, or du, sorry, just du, okay, du, and then the u from 0 to 1. So u from 0 to 1. All right. So now when you do integration, integrate second squared theta is basically tangent theta. Then the next is going to be u cubed over 3. Limits from 0 to 1. All right. So now let's continue. Tangent pi over 4 minus tangent 0 plus a squared over 2. So when you replace the u by 1, 1 cube is still 1. So 1 over 3 minus 0. So now a squared over 2. Tangent pi over 4 is 1. Okay, since these two are in common, we can factorize. Then here plus 1 over 3. So you will get a squared over 2 bracket 1 plus 1 over 3 is 4 over 3. At last, it will be 2 over 3 a squared. So this is the area. Okay. Now D, find in the form y equals to fx the Cartesian equation. So r equals to a second squared theta. So for Cartesian equation, we know that x equals to r cos theta, y equals to r sin theta. Okay, now we need to get the r. So r is basically square root of x squared plus y squared. Okay, and we need to get what is the second theta. So second theta is 1 over cos. So from here, from the x, so I know that cos theta is going to be x over r. Alright, so second theta is 1 over cos theta. Therefore, it will be r over x. So now substitute all this into your given polar equation. So the r is square root x squared plus y squared. Then a second square theta squared the r over x. So I will be getting ar squared over x squared. The left side is square root. Now, Cartesian equation, so from here, right, we still have the r. Therefore, the r must be replaced by the x and y. So I will get x squared plus y squared. Then this x squared can be moved up. Okay, and then we may square both sides. So when I square both sides, I will get x divided 4 for the left side. Then here, x squared plus y squared equals to a squared bracket okay, wait. Right. Now, basically, the r, a is second squared. So r over x squared. Okay. Let me check. Your r is a second. So, alright. So now, basically, okay, if you notice that here is this is r, here is also r. In the beginning, we may cancel off the r. Alright, that it will be easier. So no need to change to this, it will be r. So now, here, next term is going to be r squared. So the r can be cancelled off, right? Then it will be easier. So which means now I will get x squared. Okay. Now I can move up the x squared. Then it will be just ar. Okay, so now your r is a square root. This will be easier. Then here x squared. To eliminate the square root, because we need to get the Cartesian equation, so you may square both sides. So x divided 4 is a squared bracket x squared plus y squared. Then you may get the y as a subject now. So a squared x squared plus a squared y squared is x divided 4. So your a squared y squared will be x divided 4 minus a squared x squared. And hence you divide by a squared. Alright? So, and at the same time, x squared is in common. So here, x squared minus a squared. And at last, your y will be just square root. So now, alright, square root. So you may write this is x over a square root of x squared minus a squared. Okay, so this is your Cartesian equation. Cartesian equation means no xy. No r, no theta. Okay, it will be just x and y. So this is your solution. Now, question 6, which is vector question. Now, the lines L1 and L2 have equations r equals to 2i plus k plus lambda of I minus j plus 2k. And the second line, this is L2, this is L1. L2, the equation, or the vector equation of L2 is r equals to 2j plus 6k plus mu times I plus 2j minus 2k. Right? The point P on L1. So most likely this will be the OP, vector OP. And then the Q on L2. This is the position vector of point Q, such that PQ is perpendicular to both L1 and L2. Right, find the length of PQ. So when PQ is perpendicular to both L1 and L2, which means PQ is parallel to the B1, the first direction vector, and the second direction vector. Okay, so now we can find the cross product. So B1 times B2, this is a B1, here is a B2. Two direction vectors, it will be 1i minus 1j, so minus 1 plus 2k, cross with 1i plus 2j minus 2k. So here, when we multiply or cross multiplication or cross product, right? So it's basically plus, keep the first row, then get the cross multiplication. So minus 1 times minus 2 minus 2 times 2. The sign is plus. Then ignore the first row. Now we cover the second row. So we cover the second row. Again, we do cross multiplication. The sign for second row is minus. So 1 times minus 2 minus 2 times 1. Lastly, we cover the third row. Okay, so we cover the third row and do cross multiplication. So 1 times 2 minus 1 times minus 1. So I will be getting minus 1 times minus 2 is 2. 2 minus 4 is minus 2. 1 times minus 2 is minus 2. Minus 2 minus 2 minus 4. But there's a minus outside, so it becomes 4. 2 times 1 is 2. Minus minus is plus 1. Therefore, 3. Okay, so the PQ, the vector PQ is parallel to this vector, minus 2, 4, and 3. So now, to get the length of PQ, okay, I need to find the difference of the vector first. So now, from the second line, 2j plus 6k. All right. So, for the first line, this is 2i plus k. I can write this as 201 minus 201 because of 2i plus 0j plus 1k, which is from the L1. I minus the second point, or the point on the second line, 2j plus 6k, which means 0i, 2j, 6k. So when I minus, this will be 2 minus 2 minus 5. Okay, so once I found this, then now I will just write my PQ is absolute value of minus 2, 4, 3 dot with 2 minus 2 minus 5 that we found here over the magnitude of the B1 cross B2. All right, so for the numerator, that is the scalar product. So minus 2 times 2 plus 4 times minus 2 plus 3 times minus 5 over Okay, the denominator, I will be getting square root of 29. So now here, this is modulus or absolute value of negative 27 over square root 29. So you may leave your answer in 27 over square root 29. This is the length of the PQ. Okay, now the plane pi 1 contains PQ and L1. The plane pi 2 contains PQ and L2. Write down an equation of pi 1 in this parametric form. All right, so you can just write R equals to, now any points, okay, because contains PQ. So you can just take any points. Now I may take the first point, right, 2, 0, 1. Okay, my first point. Plus S. Okay, now what is the B? Right, the B contains, the pi 1 contains PQ and L1. So the L1 has direction vector 1, minus 1, 2. Okay, and then at the same time, it also has PQ. So here you write 1, minus 1, 2 first, plus T. Okay, the direction vector of PQ. So go back to previous step. PQ is parallel to B1 cross B2, which means you can take this as the vector PQ. So minus 2, 4, 3. There is a direction which is parallel to PQ. So minus 2, 4, 3. Okay. So done the B part 1. And then for part 2, find an equation of pi 2 and leave the answer in Cartesian form. So now, to get the pi 2, because pi 2 contains PQ and L2. So now we need to find what is the vector, right? So let's say this is a pi 2. This is pi 2. It has the L2. This is the L2. L2, we have B2, the direction vector of the line. And this is a PQ. Okay, here is a PQ. Here P, here Q. Let's say, for example. So probably I can just write PQ over here. And then now your plane pi 2 has N2. So N2 is perpendicular to both of these. All right. So now to get the vector which is parallel to the N, right, which is the cross multiplication. So this 1, 2 minus 2 is from the line 2, here, B2. Okay? So now, when we solve this cross multiplication, so it will be plus of, okay, so you cover the first row, 4 times minus 2, I get minus 8. Then minus 3 times 2, it will be 6. Then minus second row, when you cover second row, it will be minus 2 times minus 2, which is 4. Then minus 3 times 1 is 3. Plus, now cover the third row, it will be minus 2 times 2, minus 4. Then 4 times 1, minus another 4. All right. So this is basically same as negative 14, negative 1, and minus 8. Right. So now from here, I will say that equation of pi 2, it will be xyz dot 14, 1, 8 equals to the point. So I will say that the point is 0 to 6. Okay, which is a point on L2. Then 14, 1, 8. Now, perform the scalar product. So 14x plus 1y plus 8z equals to 0 times 14 is 0, 2 times 1 is 2, plus 6 times 8 is 48. So at last, we'll be getting 50. Okay, that is the equation of the type 2. Now, last part. Find the acute angle between pi 1 and pi 2. So, we need to get the cross product. So, 1 minus 1, 2 times with minus 2, 4, 3. Okay, so here it will be plus. Cover the first row. So, minus 1 times 3, okay, minus 3, minus 2 times 4, 8. Negative. Second row, cover the second row. So 1 times 3 is 3. Then minus 2 times minus 2 is minus 4. Okay, now lastly, the sign is plus. Then cover last row. 1 times 4 is 4. Minus 1 times minus 2 is 2. So from here, I will get minus 11. Then 3 plus 4, 7. So minus 7. And then here is 2. Right. Now, you may factorize negative. Right, because the two terms are negative. Otherwise, you can just leave it. So I may factorize negative. Then I will use 11, 7, and minus 2 to calculate. So 11, 7, minus 2, dot with 14, 1, 8. This 14, 1, 8 is from the previous part, which is here. Right? So it will be square root 11 square plus 7 square plus negative 2 squared. And then here 14 square plus 1 square plus 8 squared cos theta. So when you multiply, right, left hand side, square root 174, square root 261 cos theta. Then now the calculation will be for the left side. Right side, you may just copy. Okay, then the theta will be inverse cos. So at last, you'll be getting 47.1 degrees. So that is the solution for the part C. Acute angle between pi 1 and pi 2. Right? So now let's move on to last question, question 7. The curve C has equation y equals to x squared minus x over x plus 1. Find the equations of the asymptotes. So firstly, the numerator degree is 2 and the denominator degree is 1. Therefore, we have to perform the polynomial division. Alright, so x squared minus x plus 0 divided by x plus 1. So we need to times x to x in order to get x squared. X times 1 is plus x, then minus. Now, first term will be 0. Second term, minus x minus positive x is minus 2x. Then times another minus 2, minus 2x plus, or minus 2. Then we minus again. 0 minus minus is a 2. So the remainder is 2. So from here, we know that the asymptote, we will have two asymptotes. First asymptote is the oblique, y equals to x minus 2, which is from here, from the quotient of the polynomial division. And the second one is we let the denominator be 0. Therefore, my x is minus 1. Now, B, find the coordinates of the stationary points on C. So for stationary points, you can either use the division or you use the original function or original equation to differentiate. Okay, so to avoid any mistakes, you may always consider the original function or equation. So now, I use the original equation. X squared minus x over x plus 1. This is minus. Alright, so to differentiate this, we need to apply the quotient rule. So according to quotient rule, square the denominator, rewrite the denominator, and now differentiate numerator, you get 2x minus 1, always minus. Keep the x squared minus x. Differentiate x plus 1 is 1. Okay, so now can do expansion. So x times 2x, 2x squared. X times minus 1, minus x. 1 times 2x, 2x. 1 times minus 1, minus x. Again, and here do expansion. Minus x squared plus x. And now we simplify. 2x squared minus 1x squared, x squared. Minus x squared plus x squared, 0. Then plus another 2x. Then minus 1 over x plus 1 squared. Okay, so now to get the stationary points, we always let dy dx be 0. Okay, so let dy dx be 0. So we know that denominator cannot be 0. Therefore, x squared plus 2x minus 1 equals to 0. Now, solve this by using quadratic formula. So it will be minus b plus minus square root of b squared minus 4ac over 2a. So hence, you'll be getting minus 1 plus minus root 2. Okay, so for the stationary points, so when x equals to minus 1 minus root 2, your y will be x squared minus x over x plus 1. So x squared minus x over x plus 1. Right, so here will be 1 minus 2 root x, 1 plus 2 root x, 2 root 2, then plus 2. Okay, when you do expansion, then move in the negative, plus 1 plus root 2 over negative root 2. So at last, you'll be getting 4 plus 3 root 2 over negative root 2. All right, so you may further simplify to negative 2 root 2 minus 3. Now, when n equals to minus 1 plus root 2, right? So use the same method to get the y coordinate. So here will be all these terms. So you get 4 minus 3 root 2 over root 2. And at last you get 2 root 2 minus 3. Okay, so with this, then you write down stationary points. So minus 1 minus root 2 minus 2 root 2 minus 3 and minus 1 plus root 2, 2 root 2 minus 3. Okay, so now see, sketch. Stating the coordinates of any intersections with the axis. So now we need to sketch. Just now we found the oblique. Okay, so we have to draw using ruler. Right? So the asymptote, oblique asymptote, y equals to x minus 2, then x equals to minus 1 for the horizontal asymptote. So let's say here is minus 1. Then let's say here is 2. Right? 0, 1, 2. So this draw using ruler. Right? So just now we found two stationary points, minus 1 minus root 2 and minus 2 root 2 minus 3. Basically, this is negative 2.4, okay, and negative 5.83, and then this will be 0.41, negative 0.71. So now we need to mark all these points. So negative 2.4, negative 5.83. So let's say here. Okay, so 5.83. Roughly here. Right? So now maybe I enlarge. Maybe somewhere here, according to the graph, to show that this is the maximum point. Okay, so here should be negative 5. So here negative 5. Right? Here negative 6. 5.83. Okay, maybe I adjust my labeling. I need to show that here is negative 5.83. Okay, so here is 0. Then another one is 0.41, negative 7, 0.71, negative 41, 0.41, 0.41 is here. Okay, and then negative 0.71, 71 is somewhere here. Then you just mark. So we know that for x 0, your y is 0. Okay, so make sure you draw a smooth curve. And never touch the asymptote when it tends to infinity. Okay. Alright, so this is my graph. Right, so now sketch the graph. So when you sketch, make sure you label the graph as well. So this is x squared minus x over x plus 1. Okay, so now, next, sketch a graph and find this. Now the graph is with absolute sign. And find in exact form the set of x for which the magnitude or the absolute less than 6. So what we do here is we just rewrite, okay, we just recopy the graph, but all the negative parts you have to reflect, right? So which means you need to redraw the graph. And now no more negative because of absolute value. And I still draw y equals to x minus 2. So let's say here is the 2. Right? And then look at the graph here. Basically, it will cut at the 1, right? So 1 and 0, it will be flipped. So I'm going to flip my graph. This is supposed to be the asymptote. So I'm going to flip my graph. This is 2. Here is 1. So here is 0. We'll flip it. And there's one asymptote here, minus 1. So here is going to be flipped up. Okay, and then another graph is at this point. So this point is when the x is minus 2 over 4, 2.4 and negative 5.83. So minus 2.4 is somewhere here. This is minus 1, minus 2, here minus 3. And 5.83, so we flip 1, 2, 3, 4, 5, 6. So 5.83 somewhere here. Right, then we will get this graph. Okay, so you need to flip. Because it's supposed to have the vertical line, I mean the oblique asymptote here, right? Then you flip it. So this will be the graph with the absolute. Okay. Now to solve the last part. Okay, so to solve this, right, what we need to do is we solve equal to 6 and minus 6 first. So So get the same denominator. Right? So numerator, you get these three terms. Then now, since the denominator cannot be 0, so x squared minus 7x minus 6 equals to 0. So your x will be this value using the quadratic formula. So at last, you'll be getting two values. And here, I may factorize. So your x will be minus 2 or minus 3. So at last, when you look at the answers here, when it is minus 6 means the denominator. So we flip up, which is this part. Okay? When it is less than 6 means that you will have two values. So which means the value will be between minus 3 and minus 2 and followed by these two values. Okay, so with this we have solved the inequality. All right, so that's all for the paper. So thank you for watching. Okay, if you love my video, don't forget to subscribe to my YouTube channel. All right, and stay tuned for more upcoming videos. Okay, thank you. Bye.